Welcome back everybody. From previous some of the sessions we were able to understand what is large language model, what are the parameters, what are the probabilistic nature of the LLM and what is emergent skill. In today's video we are going to talk about tokens. So as you can see the definition I have already given you, you can think tokens in terms of Lego blocks, okay? Let's suppose if you have a word called as unbelievable. Now it's not like all the LLM will be able to see this entire word in one go, because the nature of training, how we do the training of the entire LLM. So they don't see the entire word as a one particular word. Some of the LLMs might be able to see it, but if you talk about LLMs like GPT-2 or GPT-3, they won't be able to see the entire word unbelievable as a unbelievable. Instead of that, they will be able to see in a token wise, like they will be able to see the first word as un, then believe, and then able. So it's a three tokens in one particular word, right? And if you remember from our previous sessions, we had talked about that one particular token is equal to one word, but that was not truly like a true statement. A true statement can be like this, that one word equal to 0.75, sorry, one token equal to 0.75 word. And sometimes it also depends upon the LLM. Sometimes for the one word is equal to one token for some of the LLMs. So it's truly depend upon the way different LLMs are trained. In the different LLMs we use different kind of tokens, and let's try to understand them in a now like a great detail. So if I come over here, and if you remember in our previous sessions we have talked about that LLMs are trained on this kind of data set, right? Common crawl data set, web to text data set, and books and Wikipedia data set. Now let's consider in the entire corpus of the data set I have a one sentence called as I like artificial intelligence. Likewise you will have billions of words available in the entire data set. Now, once we start training the model, we don't feed this entire sentence in one go. Instead, what we do, we divide these words into sub words, okay? And reason is very simple, because if you try to send the entire text in one go, how you will be able to train the model? Remember, the way we train the model is we send the first word and then we hide the next word, then we send the previous two word, then hide the next word, right? But and that's how LLM will able to train their self, and that is how they will be able to produce also or give the probabilistic output also. But instead of hiding the word, we actually hide the tokens and not the words. And let's try to now understand token in much more detail. So let me go over here. This is a visualizer, okay? I can share the link with you, so don't worry about it. It's available on the Hugging Face. Now same sentence I have taken, that I like artificial intelligence, and if you see over here I have selected a model from the drop down GPT-4, GPT 3.5 Turbo, and text embedding ADA 002. Now for this particular model, the way this model is trained, you see I have given this entire sentence, and you see it is able to break down this entire sentence in I, then space like, space artificial, space intelligence. So this entire thing, it has four tokens, though we are using 30 characters. So in this entire sentence we have only four tokens. So roughly you can say one word equal to 0.75 sorry, one token equal to 0.75 words, right? Now the thing is, once we have these tokens available to us, we we don't stop over there. Why? Because LLM don't understand any kind of English language or any kind of language, for sake of saying. You can't say that LLM understand English or German. No, they only understand numbers. And that's what the next step come into the picture. We have to convert these tokens into something called as token ID. So now when I click on this token ID, you will see that for I we have a token ID 40, for like we have token ID 1093, for artificial we have token ID 21075, and for intelligence we have token ID 11478. Now you might ask, okay, from where these numbers are coming? So you can consider in this way, that when this model was trained, okay, GPT-4, GPT 3.5, so the trainer of this particular LLM, they have decided that, okay, they have curated the billions of word, and within the billions of words, for I the 40 was the number given to this particular I letter. Now since this is given to I, nobody else can take this particular number. Okay, no word will take this particular number in the entire corpus. Similarly, if you see intelligence, for intelligence we have given this 11478. Now no other word will take this particular token ID because it's a huge giant vocabulary they have created and they have assigned it. But let's say, if I change the number, let's say if I change maybe to GPT-3, and as soon as I do this, and now if I go to token IDs, you see for GPT-3 the token IDs are different. For I it is same 40, but for intelligence it is 4430. Whereas if you check for GPT-4, it's not 4430, it's 11,478. Let me change to maybe some, let's take an example of Mistral V3. Okay, so let me go to token IDs. You see for the Mistral V3 we have 11,663 token ID for the word intelligence. So different models are trained on a different tokens, right? And let me give you one last example. Let's take an example of maybe Llama 3 model. So let's click over here, and if I click on the token ID, you see for the Llama 3 we have 11478. So different model is trained on a different tokenizers, and that's why they have different token IDs. And the process of converting this entire English sentence into this plain number is called as tokenization. And why it is required? Because no machine learning algorithm or no large language model, or for sake of, you can say, no mathematical model understand your English or understand your German language. No, they only understand the numbers, and that's why it is necessary to convert the your plain English to a tokens, or you can say numbers, and these numbers are called as tokens. And when you go to ChatGPT, and when you type hi, hello, or any kind of messages, so internally these words are converted into token IDs like this. Okay, then only your entire LLM will be able to process this entire text. It's not like you're sending hi and it is going hi in the entire LLM architecture. No, it is being converted into something called as tokens, right? I hope you are now able to understand what is tokens.